Okay, today we're going to look at, instead of area, which is what we did before break, today we're going to look at volume. And what we're going to do is we're going to take this, a function, we're going to bound it from A to B. Right now, as you look at that shape, does that look like a two-dimensional shape or a three-dimensional shape? Two-dimensional, yes. Okay. So what we're going to do is we're going to create a three-dimensional shape. And we're going to create that three-dimensional shape by spinning it around the x-axis. So I'm literally going to take this and I'm going to spin it around, okay? As I spin it around, it's hard to draw a three-dimensional shape on a two-dimensional space, but I'm going to do my best, okay? As I spin that around, you know, that part will come down there. And maybe a better way of viewing it is if we wanted to find the area of the original region, we would draw a rectangle. What thickness does that rectangle have? dx. Thank you. So what I'm going to do now is that rectangle would also spin around. You know, it's part of the shape. It would spin around. So you can kind of see a little bit of what you're generating here. I'll do another one. I'll pick another rectangle that has thickness dx. Yeah, it's like you're looking at a coin. And you can see the front edge of the coin, but you can't see the back edge. Yes. Exactly. So the two lines is to show that thickness is dx. Now you can see that as it kind of looks like a ham, doesn't it? And if you're going to take that ham, you could slice it, and you're going to continue to get off these slices of ham that make a circle that have, you know, that are real thin, correct? So this is what I want you to focus on. This is the shape that you're slicing off every time. It's a disc that's real thin. Now, forget about the volume. Let's just first think about the area. You can see that the two-dimensional cross-section is a circle. How do you find the area of a circle? Pi times r squared. Now, what makes up this radius right here? The function. If you look at the height of the rectangle is the radius, which is determined by the function, right? And then if instead of finding the area, so the area is pi times the function squared, and if we wanted to then find the thickness, which we said was dx, we could use that to find the volume, right? We would just take our area times our width. And so literally, the volume of this disk is pi times the function squared times dx. That is one of those disks. How many disks do you think we would like to add up? Infinite. And so therefore, we just integrate from a to b pi times the function squared dx. Now, I wrote a formula for disks. You can actually integrate any type of area. We wrote a formula for area pi r squared. Technically, you could take any area shape and do that. You know, area of a triangle, area of a square, area of a parallelogram. Most commonly, because we're rotating around an axis, most commonly we come up with disks. Okay? So let's put this example to a nice practical piece right here. It says find the volume of the area bounded between y equals the root of x equals 4, and x equals 0, rotated around the x-axis. So the most challenging part for people is often getting the drawing, and that's what you have to be able to do. You have to be able to come up with that. Square root of x looks like this. We're bounded by x equals 0 and x equals 4. So this looks, again, identical to the area that we just examined. And I'm going to spin that around the x-axis. So if I were to draw a rectangle, and I spin that rectangle around, you can see the disk that results. Sometimes people get a better view if they just rotate the portion right at the end. Sometimes they like that better instead of doing it right in the middle. Okay? You like that one better? Okay. All right, so let's go to work. This is our shape. Can somebody tell me what is the radius? The root of x. What is the thickness of the disk? dx. So if we've determined thickness to be dx, that means that our function has to be in terms of x. That means that our boundaries will be x values as well. So we integrate, and again, as we're integrating, we're kind of what we're doing is we're taking these shapes and we're just stacking more and more of them up against each other. So you're just gonna, anybody ever eat like a spiral cut ham for a, yeah, okay, so you get the idea, right? So you see it cut up into all these different slices, and they're just kind of layered on top of each other. That's the idea. These discs are just continually layered on top of each other, kind of like when we looked at the rectangles before. So we're going to bound this. We're going to start layering them at 0, and we stop layering them at 4. And the volume of that shape is pi times the root of x squared dx. That's the volume of one of those disks. We want an infinite number. So therefore we integrate it. Pi times, what is the root of x squared? X dx. So we integrate. What is the antiderivative of x? X squared over 2, integrated from 0 to 4. So we plug in 4, and we get 8. So 8 pi. I would like you to write it in terms of pi if you can, yes. So it kind of looks like magic, but using calculus, we can, find find volume using 3 dimensions. Now, I don't want to make your brain explode, but when we integrated a 2-dimensional figure, we got 3-dimensional representation, right? So you can very easily integrate 3-dimensional figure and come up with 4-dimensional representation, which we can't even really understand. So, okay. Let's move on. Example 2. Find the volume of the area between y equals x squared plus 1 y equals x squared plus 1 is a parabola shifted up 1 unit. We have x equals 0, which is the y-axis. So we're going to bound it from there over to x is equal to 2. It says we're going to rotate it around the x-axis. So I'm going to spin it down like so. So I'll draw what part of that would look like. You could yeah, it looks like the end of a horn, right? Can you see it? So if you just look at one of those slices, it makes the shape of a disc. Well, I want to find the volume of that disc. What's the width of the disc? dx, because it has horizontal width. Well, I need pi r squared. What's r? So that means that the volume of just one of those discs is pi times r squared times then the width, which is dx. So that's the volume of just one of those. How many do I want? An infinite number of them. In order to do an infinite number of those disks, stack them up on top of each other, I integrate from what to what? From 0 to 2. Pi times, if we square x squared plus 1, what do you get? And I integrate. What is the antiderivative of x to the 4th? Plug in 2, and we get 32 over 5 plus 16 over 3 plus 2. What's our common denominator? 15, so multiply top by 3, I get 96 over 15. Top and bottom by 5, get 80 over 15. And top and bottom by 15, I get 30 over 15. So the exact area is 206 pi over 15. We're going to show you one example dy, then I'm going to give you the assignment, then we're going to do one example tomorrow of dy and give you the rest of the time to work. D. Weiland. Worksheet. It's a worksheet. Well, I guess it's kind of a packet. Let's try another one together. We're going to switch this problem. Find the volume of the area bounded between the curves y equals 1/2 x plus 1, x equals 0, and y equals 4. We're going to rotate around the y-axis. Okay, so D. Weiland is seeing something important here. First of all, let's generate the shape. That's y equals 4, right? And then 1/2 x plus 1, that's going to be a line, the slope of a half. It goes through 1 on the y-axis. So that's a triangle. And then it says bounded also by x equals 0. That's the y-axis. So this is the area that I'm trying to rotate. I'm rotating again around the y-axis. So if I rotate it around like so, Darren sees that it does make a cone. Is everybody in agreement there? YouTube world, my class is freaking out right now because it's free cone day at Dairy Queen, and that's all I could think about is getting their ice cream cone from Dairy Queen. Okay, let's bring it together. Even if you don't get a free cone at Dairy Queen today, you could pay for one tomorrow, and it really isn't that bad of a price. So you could join track and field and then run there and get a free cone, and that way you get exercise as well. Choosing not exercise is a great choice. All right. What is the thickness of this? Yeah, very good. D. Weiland. Very good. So dy is the thickness, so therefore everything has to be in terms of y. What? It's a lot of practice. It's very difficult. Yep. So when you look at this radius, you might say it's y equals 1/2 x plus 1, but you can't write it in terms of x because the thickness is dy. So therefore, everything needs to be written in terms of y. So I'm going to subtract the 1. Y minus 1 is equal to 1/2 x. I'll multiply by 2. 2y minus 2 is equal to x. So sometimes people struggle with that, and they're like, well, does that really work, Mr. Gens? Well, just pick a point. What is that? What is this y value right there? That's a y value of 2, right? So hopefully it corresponds to a positive x value. Let's just see. If you plug in 2, we get 2 times 2 is minus 2 is. So does it seem reasonable that if this was 2, then this would be 2? Yeah. So you can tell that this generates x values given a certain y value. So that will tell us that height. So we can think about the intersection. It's not going to actually be 4. It'll be a height of 4, but the x value would actually be 3, correct? Now, let's understand what we're actually looking for here, though. You're stacking these washers on top of each other, aren't you? These discs, excuse me. We're going to do washers later. So as we stack these discs on top of each other, at what height do we start to stack them? we start to stack them at 1. At what height do we stop stacking them? 4. See the difference? And then it's pi times the radius, which is 2y minus 2, quantity squared, and then dy. So let's square it out. Pi times the integral from 1 to 4 of 4y squared minus 8y plus 4. What's the antiderivative of 4y squared? 4y cubed over 3 minus 4y squared plus 4y. We're evaluating it at 4 and 1. All right, 4 to the third times 4 is 256. 256 over 3 minus 64 plus 16. We plug in 1, we get 4/3 minus 4 plus 4. We're going to subtract those two expressions and then multiply by pi. Minus 4 plus 4 goes away. We'll combine kind of like terms here. 256 over 3 minus 4 over 3 is 252 over 3 minus 64 plus 16. 2 plus 5 plus 2 is 9, so that's divisible by 3. 84. We get pi times 84 minus 64 plus 16. Uh, 20 plus 16 is 36. The exact volume is 36 pi. So we're going to spend 2 days on this topic so that you can feel confident with it on your worksheet. I'll hand that worksheet out to you. And tomorrow we're going to do one more example problem together. And that'll be it. It's time for the packet. So tomorrow what I'm going to do is I'm going to start giving you guys worksheets where all the problems are just kind of listed with one space between them. That way it will be a worksheet. No, if it be a worksheet, you just have to do it scratch your. Yeah.